right. You guys had your lunch? Well, go grab your lunch, man. Come on. This is a lunch break. All right, excellent. So how many of you know what an Ignite format is? Oh, lovely. How many of you are giving an Ignite talk then? Few. Well, we definitely want to see more hands going up next year. Now, you guys made our job too easy for selecting which Ignite sessions we need to pick. We need way more submissions next year. So for those who don't know, Ignite, the mantra is inform us, but make it quick. So each talk is 5 minutes long. There are 20 slides, and each slide auto-forwards 15 seconds. It's not an easy task, because 15 seconds is not a lot of time in which you can put your thoughts correctly and use the right words. Most of the time, speakers are like catching up with the previous slide. So it's fun to see those speakers, getting embarrassed right up in front of everybody. So it's a lot of fun thing anyway. So without, I know we have a limited break and we have a lot of talks that we want to get executed here. So what I'm going to do is I'm going to fire up here. So Bas is my very first speaker here, and as soon as I hit Control L, as soon as the screen goes live, your 5 minutes starts now. And when the screen goes live, and there is no cheating involved here because the computer is doing 15 seconds automatically every time, and I'm not touching it. All right? So, thanks. You ready? Yes. You want to hold the mic?
Yeah, sure.
And 3, 2, 1, and go live.
Hi, welcome everyone to this first Ignite session on reactive programming in practice. My name is Bas Knopper and I work for JDriven, which is a small and awesome consultancy company specialized in the JVM. Let's have some fun. We're going to talk about reactive programming, and reactive seems to be everywhere nowadays. I mean, it's the buzzword to drop at any developer's party right now, next to microservices, obviously. But I'm going to let you in on a little secret. Any developer that starts developing with reactive programming soon starts to look like this. Because it's tough. I mean, to grasp the concepts of reactive programming requires a different way of thinking about data. Because normally we have this static kind of data that we retrieve from the backend side. And if you look at it as being a body of water, we are like bucketing with REST APIs. We're grabbing this water, getting the data, reading it, showing it to the user or whatever. But some types of data nowadays, especially nowadays, look like this. I mean, it's this big stream of data coming at you, and you're there with your bucket, you're going to have a bad time because you can't keep up with the stream. So we have to think differently about how we tackle this, simply because data has changed. Look at Twitter. This is your Twitter feed. Tweets keep coming up and up and up, and you're getting all these tweets on your Twitter feed. This is a good example of a stream of data, and REST polling this isn't that smart to do with a stream of data. You want to push it from the source to the clients, the people that are interested in this data. Right? And if we are able to do that, then we'll be able to actually use the characteristics of this stream, tap into it, declaratively state, I would like to do this and this and this with the stream, or I like this and this data, or I'd like this and this for the next piece of data that comes along. And what we eventually would like to do is, we all hate this guy, right? We hate waiting. All of us hate waiting. So we want a responsive, reactive system. We want to build that, and with the new types of data, streaming, we would like to look at it that way. Netflix had the same, they apparently have some streaming issues, or they had them, so they thought, why not use this 30-year-old concept, reactive programming, and build it into a library called ReactiveX? And what they basically did was implement the observer pattern, but on steroids. As in, okay, I'm a subscriber, and I know this is a stream of data, and I would like to declaratively state what I would like to do with it. So I have this observable, and I can use this observable to create streams, to manipulate streams, filter stuff, make new streams out of old streams, to just get what you want, and then actually say what you would like to do when the next piece of data comes along. So what are applicable situations here? 2 weeks ago, I gave a presentation on GeekOn, on evolutionary algorithms, and I made a demo with a backend, which did some computation, and I wanted to show intermediary results like these. And what did I do? I made a REST interface. Why? That's not smart. I should have pushed the data to the front end. So another good example, which you already stated before, is the public Twitter stream. This is publicly available, and you can hook into it. And I would just like to see in the short amount of time that I have what a bit of code looks like to utilize this and how easy it is to utilize this. So this is quite a bit of code, but what it actually does is just get an observable, a stream, so create one using the Twitter4j library, which is a library you can use to enable Twitter for Java. So I created the stream, I have the stream. So now what? I'm getting all these tweets, but I don't want to know what Justin Bieber ate last night, right? I want to know stuff about Java. So I'm going to filter this stream by saying, okay, I have the stream, but please filter it by checking, hey, only pass through data to the next stream if it contains Java and if it's English, because I don't know Japanese, unfortunately. And then subscribe to this new stream and pretty print it for me, please. And what this looks like, and I just ran this in my IDE, and now I have this stream. So I put it on, I run it, and now I get an endless stream of data, of tweets, that adhere to the constraints I just put on it. And now I have this. I hope you're ignited. I know it was a really short time to explain all of this. Here are some resources if you're interested. These are some companies that actually were ignited and use this. Thank you so much for all your attention.
Excellent, thank you so much. And I'm certainly delighted to see Couchbase logo over there. We should talk more. All right. Now the next speaker is Linda. How many of you know of Duchess? Okay, before we start with the formal talk here, Linda, you want to talk, 30 seconds, talk about Duchess, what Duchess program is?
Oh, that Duchess is a network for women who are interested in Java. So they can be students, they can work with Java for years and years. So if you know any women, point them to the Duchess site, jduchess.org. Thank you.
Excellent, and hopefully we'll see more women, speakers and attendees next year. Look around you. How many more men are available? Gosh, that's disgusting. And your time starts now.
Great, then my timer is off. So, welcome to this presentation about sketchnoting. My name is Linda van der Pal and I work at eProfs. And my Twitter handle is on the slides. It's Duchess Founder. And during and after conferences, you can usually see my sketch notes there. So what are sketch notes? Sketch notes are regular notes enriched with color, images, structure, arrows, lines. So pretty much anything you can see in the tiny little sketch there. Sketch notes might remind you of mind maps. You've probably heard of those. So you might wonder what the relationship is. Well, for me, a mind map is sort of like an element of the group of sketch notes, of the collection. So a mind map is a sketch note, but a sketch note not necessarily a mind map. Sketch notes are all about ideas and not art. So while the ideas on the left are the same as the ones on the right, they're a lot easier to draw and therefore a lot quicker to draw. And anybody can recognize them. So you might wonder why you would do this. Well, the first reason is that it helps your memory retention. When I went to conferences before, I could never remember what I'd seen. The second reason is that it forces you to improve focus and concentration. It forces you to listen really carefully because drawing takes time and you might just miss a wonderful image that the speaker throws at you if you don't pay attention. Reason number 3 is that research shows that notes written by hand yield much greater understanding than those that are typed. And if you add images to them, they stick much better to your mind and they will help you to visualize connections. Reason number 4 is that it forces you to think, process and filter the information during the presentation rather than afterwards. Because once again, drawing takes time and you have to summarize really quickly. And the final reason, of course, is that it's a lot of fun to do. It turns even boring presentations into really cool ones and that you can focus on. And you get a lot of great reactions from people and they all say things like, I wish I could do that. So now we come to the actual reason of how. If you ask any adult and if they can draw, the answer will invariably be, no, I can't. However, if you went back in time and you asked them when they were kids, they would have said yes. So what happened? Did they unlearn drawing? So just try it. No matter how crappy your drawings are, people will say they're awesome. Trust me, I've been there. So I just told you that you too can do this, and after the presentation you can get some pens and pencils. So tools. Just use a marker, a pencil, a pen, some paper, doesn't matter what. You can even do it on an iPad if you prefer. I prefer paper. And just try them all and see what you prefer. But I don't know how to draw, you might say. Well, the thing is, everything is made out of 5 basic shapes. A circle, a square, a triangle, a line, and a dot. Everyone can draw those. They might not look perfectly round, but they don't have to. So a bowling ball is basically just 4 circles. A house is some squares and rectangles, and maybe a squirrely bit if you want some smoke. So the trick is to learn to recognize the 5 basic shapes in the objects around you and to simplify them. People are hard to draw, but fortunately there are basic patterns for it too. So you can use stick figures, or go slightly fancier and use the star method, or the more fancy gray method, which is a square and a bunch of lines and a circle. Then the final hard thing about sketchnoting is writing. People always say, but I can't write neatly. Well, go slowly, write less. You'll be surprised how nice you can actually write. And after some practice, you can add some of the other fancy lettering. There's the structural aspect of sketchnotes, like a mind map that has a specific template. There are several other patterns you can try and use, and try some of them and find which one suits you best. Then there are 2 approaches to sketchnoting. One is to do it real time, which is what I usually do because I'm too lazy to finish up afterwards. And after the presentation, you have a full sketchnote and it's done. Or you can do some sketching during the presentation and then redo it at home and make it look better. So how to do it? Well, just try it. Do it often. Every presentation you go to, try and make some sketchnotes. Practice, build yourself a visual library, and see where you can get. And I'd like to give you some references. There's the Sketchnote Handbook by Mike Rohde, which is the ultimate manual on how to sketchnote. There's the Sketchnote Army, where you can see the work of your peers. And there is a book called Bicablo, which is a visual dictionary, which gives you lots of great examples on how to draw stuff. So go out and sketchnote and drop by the eProf stand, where we'll have some tools for you, and you can win a nice prize with these 2 books in it. Thank you very much.
Excellent, Linda. Thank you very much. And those are the kind of presentations that we like to see more and more during these Ignite sessions. You've already had a technical overdose, in the mornings and the afternoons. So these sessions are more meant to ignite you in a completely different dimension. All right. So we're going to go to our next speaker now. And let's see if Jakub is here. All right, reverse engineering the clean code. Let me know when you're ready. All right? Yes, sir.
Okay. So hello everybody. My name is Jakub. I came here from Poland, and I would like to ignite you with reverse engineering the clean code. It wouldn't be like reverse engineering the Java class, the .class file into a Java file. It'll be a little bit different mental trick. So it'll be a kind of a story where I think we all have been, where we are doing some coding, especially at the beginning of our career. And we had this, cutting corners approach, or we thought, okay, I'll put a comment over here, but we didn't. And then after some time, when we get back to the code after 6 weeks or just next morning, we say like, what? And then we thought, okay, I'm definitely doing something wrong, so let's start to see different paths and just look how I can do it better. Just look for inspiration. So we get into those 2 guys. So we get into Uncle Bob and Kent Beck, and we read the clean code book, and we see, okay, there's a single responsibility principle. There are some other principles. There are patterns. There's implementation patterns from Kent Beck. There are some values we have in IT. There are some values we follow, like we look for simplicity or for flexibility, and we do it for the reason. And as we go this path from apprentice to master, and we get, all more and bossy thing with all the clean code, we start to think whether, okay, am I doing it just for the prettiness, just for the aesthetics of my code? I know when you look into a Google Guava library, it just looks beautiful. But is it all, or you just start to look for different patterns? And one of those patterns is that when you look at the nicely designed things, your brain just subconsciously know how to interact with that. When you see that chair, a famous Emus chair, you just think, okay, I'll just sit down, have a coffee, and read a book. And your brain is just triggered. And when you do this with code, you start, okay, I'm doing the clean code stuff, but I see that my brain is operating much better and better when I work with the good code, with the good quality code, not with the shitty code. And I will explain it why based on this box. This box has some features. You can open it, you can grab it, shake it, lift it, and whatsoever. And this set of features is called affordance. Affordance is a quality of an object which allows an individual to perform an action. For example, a knob affords twisting or perhaps pushing, while a cord affords pulling. This is something we see in every day in our life, like these doors. You know you have a handle, you know that you need to pull it, you see a slide, you know that you have to push it. That's kind of a no-brainer, and our brain is just prepared to work that way. Obviously, we fail many times on many levels, like the Jedi entrance. We add this complexity or even confusion that, in fact, we know our brain knows to push it, but the sign says to pull it, and then we know we're kind of confused. And the term affordance is something called by Donald Norman in his book Design of Everyday Things. And this is a book about designing a physical object, designing a physical things like a kettle, like a chair, like any other physical thing. And you can think how it relates to code, how it relates to IT. Well, with this simple Android example, I think you might get a clue. What's in the rectangle? You see a trigger, so you thought, okay, it's just a switch, but in fact it's a button. When you push it, you get to another menu, and it's like, what? And the thing is, okay, we see it relates with IT, but how on earth it relates with coding activities? I think you'll start getting the clues, because I think everybody was in a situation on the project where what we've been faced with was like this one, like, mother of God. I just want to ask somebody else to commit the fix that the glit blame will tell that it's his fault. And my theory is that the code, the source code, has its affordance. When you see a simple example, see this SQL class. It has some features. Yeah, I know it breaks some single responsibility rules and so on and so forth. But it also tells you how you're going to approach this code when you just want to add another feature, and how different will be approach if you set this strategy pattern and encapsulated functionality in different classes. This simple code just affords a different action. It just shows you how you should act differently on the same piece of code. So even though the term affordance is coming for a very physical object, it can be applied to something else. And what I would like to encourage you is to have a look into a book from totally different domain, like design. So when next time you will have some time to grab a book, don't look for another framework. Just take this one, and maybe it will inspire you one more time. Thank you very much.
Excellent talk. I mean, this is beautiful because this is exactly how we should be designing software. Intuitiveness is so important. But don't take it too far out where you say, hey, you know what? I'm just going to make the software so damn extensible that it's very hard to build the original software itself. All right, I'm going to go to our next speaker. And that seems like a fun talk. And you're live.
Okay, thank you. Well, I'll just skip the first slide because that's part of the framework. But this talk is about high-speed sailing. And I'll wait for a second for it to start, because 15 seconds is sometimes a very long time. Because this is just a short introduction of myself. I'm just a nerd, a blogger. But most of all, I'm a sailor. I love the water, to be on the water, to do crazy stuff on the water. It's not just on the water. I like to go under the water as well. Most of the people here in the Netherlands started sailing with boats like this. It's so much fun to go to a lake and see in the early morning. This is a fucking morning where kids 6, 7, 8 years old start sailing. But when they grow up, they want to do this. Because this is speed sailing. These boats are doing 70, 80 kilometers an hour. That's the ultimate speed challenge you can get currently. The next slide, this is the ultimate challenge on endurance. Those guys sail around the world in, give or take, 9 months' time. They do 70,000 kilometers in just 9 months. And it's a long way. But why it's fun to start sailing in the speed? Speed is fun, always. All adrenaline junkies here. It's outdoors. You're playing with dynamics. You're playing mind games when you do races. You endure the elements as well. And there are a few more. This is the same picture we just had. You see they're doing 40 knots, and a knot is about 1.8 kilometers an hour. So they're doing, give or take, 75 kilometers an hour, and they're speeding. But you're outdoors as well. So if you're outdoors, why don't go for a walk? It's a bit creative to do it on a keel of a boat, but it's good advertising for Hugo Boss in this case. And that's the fun you can do on the outside. Well, dynamics. You want to go underwater or you want to go over it? The left side, the catamaran, that's the cool thing to do when you're sailing, jumping a wave. The other one is not so good, because you have to understand you're doing 40 miles an hour and then you go into the water. You gotta have balls. Those guys are doing 40 miles an hour as well. And they're, give or take, a meter away. And you just saw, I've got right away. Go away, you guy. I have fun. But this is just a plain day in the office. Yeah, there's some waves. And, there's a little bit water on the boat. But yeah, well, it happens. But it's working. It's very hard. And by the way, this picture, the water is about 5 degrees. Sometimes, most of the time, we win from the elements, because this is the start of around Texel. And you start by going through the surf, and those waves can be very big. Most of the time we win, but sometimes we lose and we flip backwards. The boat you see here is a skiff 18 feet. It has 115 square meters of sail on it. And try to control that one with just 3 guys. Because this boat is doing, give or take, 50 kilometers an hour, and you gotta work hard. It's still affordable, the sport. The boats you see here, I think the most expensive boat you see here is about 50,000 euros, but the cheapest one is, give or take, 20,000 euros. Yes, still a lot of money, but you don't have to start with a new one. How can these boats go so fast? It's just math. We all had factors in school and stuff like that. The only trick we're looking for is apparent wind. Because if the boat has speed, the wind direction shifts. And that we can use. And so you want to build a small boat, a light boat, with a lot of sail on it. This is a small Optimist that weighs about 40 kilos. And the other sail is about 70, 80 square meters. If you combine those, you can go hard, very fast. This is a thing you have to be aware of. The law of Archimedes, the tilt, you're always trying to balance your boat on that edge. Because when you balance your boat on that edge, you have the most speed. You can watch it currently. It's even fun to watch, even if you don't know the rules. All the TV shows, they have excellent techniques to make it fun to watch. And there are only 8 rules. So you can learn them in just 10 minutes. If you want to go have a good watch here in the Netherlands, go to around Texel. That's a race around the island of Texel. You got 600 boats there. And they all start, it's a mass start, they all start at the same time. And when the direction is good, it's excellent to watch. But it's all about choices. You can buy a phone for 1.3 million euros. You can buy a kite for 1,200 euros. It's even cheaper than the average MacBook. So, you want to want more? Just take a course and start sailing, because we have a lot of sailing schools here in the Netherlands. And there's a lot of fun to do. Thank you.
Excellent. You know, if you've ever been to San Francisco Bay Area, Larry's boat particularly.
I want to go there.
Well, it's the most beautiful city in the world. So sure. After Netherlands, probably. So if you have ever been to San Francisco Bay Area, Larry's boat is typically on a display over there. So come by. You know, it's a beautiful sight, and I totally understand the amount of endurance and strength and courage it takes to do sailing. Oh, Larry invites all the employees on the boat all the time. Yeah, we all live there.
Have you seen those guys that work on that boat?
Yeah. My actually home office is on the boat. Used to be. Now I don't work for Oracle anymore. All right. Let's see. We're gonna see some fireworks here. Yeah. All right. Let it go.
Oké, snelle tips over Lambda's en Java 8. Ja, wat zijn nou dingen als je met Java 8 aan de gang gaat, Java Lambda's? Een aantal handige dingen om te weten, zodat je snel aan de gang kunt en snel productief mooie code kunt schrijven. Nou, als je net met Lambda's aan de gang gaat, dit is nog even een korte refresher, waarschijnlijk heb je het al 100 keer gezien. Lambda's zijn gewoon inner classes, maar dan wel goed, zeg maar. Dus ja, waar je vroeger heel veel code nodig had, kun je nu alles met een raketje oplossen. Wat wel heel vernieuwend is dat je waarschijnlijk als je Lambda's gaat gebruiken het heel vaak wil gaan doen. En daarvoor heb je heel veel nieuwe API's nodig. Dus dit zijn een aantal voorbeelden die daarvoor in Java 8 te vinden zijn. En dat is eigenlijk de grootste stap. Maar nu ben je Java Lambda's aan het gebruiken. En ja, dan ga je expressies in expressies schrijven. En dat wordt al snel een zooitje. En de rest van Java is eigenlijk niet veranderd. En dat geeft af en toe wel wat scherpe randjes. En daar ga ik eigenlijk vooral het over hebben nu. Nou, als je met Lambda's gaat beginnen, dan is het eigenlijk de meest simpele vorm van het gebruik van een Lambda API. Net de korte raketjes, waarbij je verschillende Lambda's onder elkaar zet en alles is lekker simpel. Maar die raketjes kunnen al snel moeilijk worden. Dit is een voorbeeld van een recursieve Lambda-expressie. En ja, waarschijnlijk ga je dit in 15 seconden niet snappen. Dus ja, op een gegeven moment heb je meer nodig dan zo'n raketje. En daar zijn methodereferenties, dat zijn hele mooie constructies waarmee je eigenlijk vanuit een Lambda-expressie weer terug kunt naar gewone Java-code, wat je al kent en waar je al heel goed weet hoe je onhoudbare code kunt schrijven. Maar ook die methodereferenties hebben op een gegeven moment zijn problemen. Je moet een instantie hebben, je kunt, als je een hele lange klassennaam hebt, kun je ze niet meer lekker wegpoetsen. En alles moet precies op elkaar passen, anders heb je er niks aan. En als je daar tegenaan loopt, dan zou ik eens kijken naar factory methodes, waarbij je eigenlijk gewoon een methode maakt die een interface implementatie teruggeeft, want dat is eigenlijk wat een Lambda is. En daarmee kun je eigenlijk al dat soort problemen wegmoffelen. Maar moet je wel iets meer code schrijven. Het leuke is van deze methodes is dat ze ook een mooie functional interface teruggeven. En daarmee kun je bijvoorbeeld ook een negatieve expressie van de is-check-norris methode heel makkelijk terugkrijgen. Allerlei standaard utilities die erop zitten, ja, dat maakt het nog meer bruikbaar. Nou, type inferencing, dat is ook een probleem waar je tegenaan gaat lopen. Lambda's wil je graag zonder types declareren, maar soms heb je ook methodes die dat eigenlijk weer verwachten dat je wel een type meegeeft en dan krijg je allemaal compiler errors. Nou, de standaard manier om het te doen staat bovenin, door eigenlijk de parameter te voorzien van een type. Maar wat je meestal kunt doen, en veel korter en mooier is eigenlijk het generic type van de methode declareren. En daarmee dat ding weggooien. Ja, legacy code, daar hebben we natuurlijk allemaal mee te maken. De meeste mensen starten niet met een greenfield als je met Java 8 begint. Maar pakken een bestaande codebase en gaan daarop voorbouwen. Nou, veel van de bestaande API's werken met abstracte base classes in plaats van single method interfaces. En Java 8, om allerlei implementatietechnische redenen, snapt dat dan niet, zeg maar. Dus een single method interface wordt wel begrepen, maar een abstracte klasse niet. Nou, dat kun je zelf oplossen door een adapter implementatie te schrijven. Dit is een voorbeeld hoe je dat kunt doen. En daarmee kun je eigenlijk van een oude API, die normaal gesproken Lambda's niet snapt, toch een Lambda sausje eroverheen gieten en lekker met Lambda's naar gang gaan. Checked exceptions, nou, die had je al sowieso, waren die niet cool en niet leuk. Maar bij Lambda's wordt het echt een probleem. Want de meeste functional interfaces die je met Lambda's gebruikt, accepteren geen checked exceptions. Dus dan moet je gaan wrappen en unchecked exceptions daarvan maken. En dat is een hoop gedoe. Ook dat kun je weer wegpoetsen door zelf eigenlijk een interface te maken die wel checked exceptions mag gooien. En dat 1 keer weg te wrappen. En ook daarmee kun je al een heleboel van dit soort ellende wegpoetsen in je legacy code. Serialisatie. Als je dat gaat gebruiken, loop je ook tegen een probleem aan dat Lambda-expressies by default niet serializable zijn. Dus dat is iets om in de gaten te houden als je nog iets met serialization doet. Hopelijk niet. Maar, Dat kun je wel verhelpen door deze creatieve constructie die ze in Java 8 daar speciaal voor toegevoegd hebben eigenlijk. En dat is door met een AND operator eigenlijk een extra interface aan je lambda-expressie toe te voegen. Dan gebeurt allerlei voodoo magic en dan is alles weer serializable. Nou, dat waren eigenlijk mijn korte tips over het gebruik van Java 8 lambda's. En ja, veel succes met het programmeren in lambda's.
Thank you so much. You know, I like how Chuck Norris has been and will always continue to be a standing joke, and how Donald Trump has started becoming a new joke. All right. And sentiment analysis of social media. I'm particularly looking forward to this. This is something I know somebody close who's looking at this as well.
I hope to ignite you.
Okay.
Okay, hello everyone. My name is Niels Dommerholt. I'm a Java developer. Just like my colleague Bas, I work with a small consultancy company called JDriven. Small, 40 people. We're based in Nieuwegein. And we work at all kinds of very cool big and small companies. ING, our sponsor, is an example. In the next slide, I'm going to explain quite a bit about sentiment analysis of a social media post. I'm going to explain the data set that I got. I'm going to tell you a little bit about Apache Spark, explain the sentiment analysis, and show you some of the results of the analysis that I did. All the stuff is will be on GitHub, so if you want to check it out, please fork me. Reddit, most of you probably heard of it, probably use it. It's a huge community of communities, user-driven content, funny pictures, cats, to political discussions, etc. And a while ago, someone was actually nuts enough to download all of it. Huge size, too big even for me to do the presentation on, so I used an extract for just around 50 million comments just 1 month, but it still was 31 gigabytes uncompressed data. So I took one of the open source big data processing frameworks, Spark. It's easy to use, it's smart, generic enough for me to do the analysis, and it's very, very fast. Just to give you a short example of what it does, this is basically the hello world of Spark. It just counts the words occurrences in a stream. Looks familiar for you, probably if you used Java 8 streams already. What's sentiment analysis? Sentiment analysis is basically a way of doing analysis that tells you if a piece of text is positive, negative, or neutral. So what was my approach in this? I used an existing word list, basically. It's not the best one out there. There are better ones, but those tend to be rather expensive because it's a lot of work to assemble those. You have to annotate tons and tons of text. So just to give a short example of how sentiment analysis works, you have a sentence, such an abhorrent sense of betrayal with a bunch of negative words. You find the words in your word list, you add them up, normalize it by dividing over the length of the text, and then you end up with a normalized score. And this is what I did in the back. Just some statistics about the most popular Reddits. This is not sentiment analysis, just the counts. You see that Ask Reddit is the most popular one. It's very generic, a lot of traffic. The most productive authors. This is also something that's very easy to do with Spark. Those are actually, most of them are bots. People don't tend to do that much on posting. And I also have a list spit out of the most occurring words. Of course, is the most occurring with 60 million occurrences in just 1 month. This is very useful to find stop words for text analysis because these words often don't have meaning, but they do occur a lot, so that's something to take into account. So going to the sentiment analysis, these are actually the words, or the subreddits with a lot of positive comments. And then when you go to the ones with the negative comments, you see actually a shift in the list. And this is not normalized, so of course the most popular ones are at the top. But you do see a shift that some subreddits are actually more positive and or a bit more negative in their tone. And I also have a list of the most positive and negative. This is the next one. weekdays. So what you see here is that in general Tuesday is the most popular or most positive weekday, and Sunday, probably because people have to go back to work, is the most negative day of the week. So why do you want to do this? Whenever you make a product, make a technology, you want to know what people think of it. And of course, there's social media like Twitter, and people respond to that. And it's very convenient to automatically detect the responses that you get to your changes. There's also a lot of challenges. Sentiment analysis is hard. It's a lot of work to annotate the bodies of text, and not even humans can decide what's positive or what's negative all of the time. So I hope you enjoyed this little piece about sentiment analysis. If you want to see the actual code behind it, it will be on GitHub very soon. And if you want to ask me anything about it, you can either contact me through my blog or to LinkedIn, and or find me afterwards. Thank you very much.
Excellent. How many of you think Sunday is the most depressing day of the week? Or Sunday evening at least. Thank you. Thank you. No. All right. We got, if I can get my mouse here. And Richard. Things you might not know about JUnit. All right. Ready? Ready.
Thanks. So, as a professional developer, you're familiar with writing tests using JUnit. I'm here to talk about some of the things you might not know about JUnit. Because even though it's a small framework, and even though you may use it every day, there are quite a few nifty things about JUnit that I think everyone should know about. So, if you think that JUnit is only about the test annotation or assertions like assert that, assert true, assert equals, well, there's actually more. For instance, take assumptions. Assumptions are like assertions, but instead of failing your test, they allow you to skip the remainder of your test. So that can be useful in a number of situations. For example, if you're in a big migration and you want to temporarily and conditionally disable some of your tests, well, assumptions let you do that. Another example is if you have an integration test that only run on a certain platform like Linux, and you want to disable those tests when you're running them on Windows. Then in that case you can pass a system property to your assumption. That system property gets evaluated at runtime and decides whether or not to run your test. So assumptions are a nice trick to have in your backpack when you're working with JUnit, and it can be useful in a number of situations. Another thing is exception testing. I'm sure most of you are familiar with the test annotation and the way it allows you to expect a certain exception. Well, there's actually a problem with that approach. First of all, you don't know where the exact exception occurred. And second of all, you can't verify the exception message itself. So there are better ways to do that. For example, you can use the expected exception rule in JUnit, or you can use a Lambda expression for that purpose. Support for exception testing using Lambda is coming in the next version of JUnit 4, which is yet to be released, but I expect to release very soon. And both approaches allow you to test the exact location where you expect an exception, as well as the message. So I already mentioned the expected exception rule, and there are actually many more rules in JUnit. And rules are an extension point of JUnit. We have a couple of rules in JUnit. For example, I think most people may be familiar with the temporary folder rule. I think that's the most common rule people know about. But like I said, there are more. For example, we have a timeout rule and the error collector rule. And some of these rules can even be wrapped into each other. So I can say stuff like, only apply the timeout rule when I'm not in a debugging session. And that can be useful in a number of situations. Also, rules can be applied either at the class level or at the method level or at both levels at the same time. So they're a pretty flexible extension unit. Another thing I want to talk about are parameterized tests. And parameterized tests are useful in the sense that you can write only one test method and you can test your code against many inputs. And that can be useful. I must say that the built-in support for parameterized tests in JUnit is a bit verbose. So, yeah, while it's there, at this point, I only want to talk about the core functionality of JUnit. I must make an exception and point to an additional library called JUnit params, which allows for much more concise syntax for writing a parameterized test. For example, with JUnit params, you can annotate the parameters right onto the test method that you want to test. Also, it even allows you to do stuff like read parameters from an external file for a much nicer syntax. Also in JUnit, we have a specialized version of parameterized tests, which are called theories. And theories allow you to test a combination of each parameter. So that's a really useful feature to have. And theories, we touched on a different subject called property-based testing. I'm not going to talk about it in depth because this morning, for the early birds, there was a whole session about property-based testing. But theories are a way to do property-based testing. And if you're into that kind of stuff, also check out JUnit Quick Check, which builds upon the theory support already present in JUnit. So at this point, you may think that JUnit is the greatest thing ever and it can be improved. Well, actually, there's a lot to be improved about JUnit. So recently, the JUnit Lambda project started, which was actually funded through a crowdfunding campaign. And some of its goals are to have a more clear separation of concerns in JUnit. So there will be a separate API for tool vendors like IDE vendors. And also the extensibility of JUnit will be improved. So you may think of stuff like it will be less reliant on the evaluation of the evolution of other libraries like Hamcrest. And of course, it tries to leverage more of the Java 8 functionality because JUnit is currently a bit lacking in that area. So JUnit Lambda, it's an ongoing project. I suggest you keep an eye on it. I expect to release, well, in a not too distant future. And in the meanwhile, try to make the most out of JUnit 4. And yeah, keep an eye on JUnit Lambda for a much more nicer syntax and nicer test in the future. Thank you.
Thank you so much. You know, you might wonder that you've been using JUnit for such a long time. You know a lot of things, but you know there's always a trick or two that you can always pick up. All right, we're almost to the last presentation now. So don't run away. Don't run away. They won't start the keynote, I've been told, until we finish this. So, all right, Johan.
Thank you. Yeah, so I'm going to talk about Lego trains. Probably all of you know Lego, so I don't need 15 seconds to explain that. But we started playing around with it, just a bit for fun and also a bit for work, so it is a bit of a combination. And yeah, why exactly did we started with it? Or, first of all, of course, no Lego was harmed, but we managed to damage 3 raspberries beyond repair, so that was expensive as well. Apparently raspberries aren't really good with heat or some USB connectors and stuff like that. Why did we start with it? We started with it because we wanted to see if we could use the same software on Internet of Things that we use normally on big servers like Java, Scala, Akka, and just run it on raspberries on Lego trains, and of course have fun. And not only we had fun, but we saw, for instance, at the Developers Day in the beginning of this year, which was more an IoT conference in the Netherlands, that it was quite popular as well. Lots of attendees wanted to see our trains. They're outside here as well, so if you want to have a look, go ahead later. But what's it about? I mean, we just have Raspberry Pis, and we have a camera at the front. We control it with an infrared transmitter. We have a speaker and an RFID reader on the train. So just a bunch of stuff to connect it together. Next to that, we also wanted to automate the track switches, because else, I mean, you cannot switch from another track, and that's not really cool. So we automated track switches with some servos and a Raspberry Pi again, and a servo board, because the Raspberry cannot power them all. This is like the original controls nowadays. I mean, it's just infrared, battery pack, and an infrared, how you call it, controller. So that's pretty simple and not really cool, because after a few meters you cannot control it anymore. So what we did was we added a USB dongle for Wi-Fi to our Raspberry Pi, and an infrared transmitter, put that on the trains, and then I could even control them from my work. During lunch, of course, I don't play during work. Next to that, of course, yeah, what's a train without train sounds? So we added a speaker as well, so we could play train sounds while the train was moving, and scare away my wife when she was at home while I was working. Other than that, we also added RFID readers so we could see where we are on the track, and based on that, do certain things. So if our train reaches the cow, then our Ferris wheel will go at speed 3. Things like that we could automatically build in to have like an autopilot. And we added a camera, because what's cooler than having a camera on your train and have live feed of your train running around. And we have a camera which displays the entire view, so I can watch it better when I'm at work, lunch, of course. We use some standard components because I didn't want to build everything myself. And for Raspberry, there's a really excellent component to stream video, or actually pictures, because video is kind of hard to stream. So this just refreshes pictures really quickly. How does it look like? This is like the application, manual control. So we can just control the trains, control the switches, we can see the cameras, we can see the position. It's still pretty simple, just play around with it. And we also have the automatic control. So we can, for instance, send a list of instructions to the train, like move that speed, play that sound, blah, blah, blah. And as I told earlier, we can also do actions based on the location of the train with the RFID. So that's another feature that we have in Autopilot. How did we do that? I didn't want to show too much code, but this is a simple example. We use remote actors, which is really simple to send calls from one JVM to another JVM. So the JVM on my laptop to the JVM on the Raspberry. Really simple. This is all that you need for it. And the best part, I mean, my train could even get beer from my kitchen. One disadvantage, I couldn't manage to automate the step from the fridge to the train, so still need a little bit of help, but challenges. Yeah, like I mentioned before, I mean, it cost me 3 Raspberry Pis, a lot of free time, but it was actually quite fun. So it takes a while. I mean, hardware is a bit more difficult than software, I think, because there's just a lot more involved. But it's fun, and you end up with something like this, and then your entire room is more or less full of Lego and stuff like that, which is really cool to play around with. So if you like it, I mean, start playing with it yourself. It's really easy to set up. And we also found out that it's perfectly viable to run enterprise software like Java or Scala and Akka on Raspberry Pis. Even on the small ones with just 1 core and really low amount of memory, it still runs perfectly fine. So you don't have to learn some C language or something like that. So it's more or less of the end. You also have Wally, which you can automate, so that's also really cool. Also with the same way as you do Lego trains. So thank you for showing up, and if you have questions about Lego, let me know.
Thank you so much. Wish that was our real work, all the time anyway. Well, thank you so much for the first inaugural Ignite sessions here. Hope we will continue here. If you guys like it, just go tell all the conference organizer, this was good. We want to come back next year again. Hopefully more submissions. Thank you so much. See you at the keynote.